Hey guys, my name is Steven Sell, and I'll be going over how to find the equation of a plane that passes through three specific points. This is chapter 11.5. And so I'm going to do the example from the textbook in chapter 11.5, number 47, where the question states the plane passes through the 3 points 0, 0, 0, which is the origin, 2, 0, 3, and -3, -1, 5. So if you were given these 3 points and you had to find the equation of the plane that contains those 3 points, this is how you would go about doing it. First things first, I like to assign each point a variable. So I used P for the first point, Q for the second point, and R for the third. I feel like those are just the standard variables that are used. And next you need to find the vector between two of the points, both starting at the same point, such as I did here. You have first I did the vector between the point P and point Q, which you simply do that by subtracting P from Q. So as you see, since P is just 0, 0, 0, the 2 points that I found, PQ and PR, are simply the points Q and R, 2, 0, 3, and -3, -1, 5. This won't always be the case. This is only the case because P is 0, 0, 0. So when you subtract that from the other points, it stays the same. But make sure you don't think that's always the case, because a lot of times it won't be, and you'll actually have to do subtraction and get different vectors. So once you have those two vectors, you want to find the normal vector between the two. You do this by cross multiplying PQ by PR. So as you see, I did that here. First, when you cross multiply, you put your pencil over the first row, that's the first column. That's how I like to do it. So cross that one out, and then you just find, you do diagonally, you multiply the first point by the last one and subtract the other diagonal. So do this one, 0 times 5 is 0, minus 3 times -1, which is -3. And then remember, when you do cross product, it's plus, minus, plus. So next you do minus, cover the second column, and do the same thing. It would be 2 times 5 is 10, minus 3 times -3 is -9. And then plus, cover the third column. 2 times -1 is -2, minus 0 times -3, which is 0. So this gives you, after doing all that math, you get 3i minus 19j minus 2k. So that's your normal vector. As you see, I wrote it again down here, so it's a little more clear. And from this normal vector, you could find the standard form of your equation, which you choose a point from the top. As you see, I chose the point 2, 0, 3, and I used that to create the equation. So what you would do is you take the first portion of your normal vector, your I portion, and you do, so that's 3, and then you do x minus the x value of the point that you chose. So since I chose 2, 0, 3, it will be x minus 2. And then you do minus 19 times y minus 0, since 0 is the y value of the point. And then take the normal vector again. You have minus 2 for the z portion. You do minus 2 times z minus 3. So this is the standard form of your equation for the plane. And then you could factor it out, do some algebra, and you come up with 3x minus 19y minus 2z equals 0. Don't forget the equals 0, because that's what makes it an equation. That's very important. You need that at the end there. So once you factor it out and you simplify it, this is the general form of your equation. And in order to check it on the applet and make your plane and see that all points are on your plane, you have to solve for z in order to plug it into the applet. So I did that here for the applet, and as you can see, just add 2z to the other side equals 3x minus 19y. Then you divide by 2 on both sides to find your function in terms of z. So first, before plugging it into the applet, before checking it that way, I like to just plug each point into your equation into your general form equation and make sure that they actually equal zero, that they are true, and you haven't made a mistake in any of your math. So I did that here for 0.203, 0.000, and point -3, -1.5. And as you can see, they all ended up being true. They all ended up equaling zero. So that's a good way to check your work. You're going to want to do that at all times. And then next you can plug it into the applet and see what happens. So here if we go to the applet, as you see, I already typed in my equation, which is 3x minus 19y divided by 2. Graph that, if it works. About to have the applet stopped working for a second. I had to restart it. But as you see here now, I graphed my plane, I put in the equation, and this is the plane that would give you. So now you want to go to graph and you want to add your 3 points to make sure that they are all on the plane. So first I put 0, 0, 0. Okay, size 4 is good, make it black. As you can see, that's the origin. That's clearly on the plane. So I'll add my next point. 2, 0, 3. 4, same thing. As you can see, that is also on the plane. And now we'll add the last point of -3, -1, 5. Okay, okay. And now zoom out once, and there you go. You see that 1, 2, 3. All points are on the plane. Therefore, we did the problem right, and there were no mistakes. And that's how you would go about finding the equation of a plane. Any questions, feel free to comment them. I'll be happy to answer them. Thanks.